Hello, everyone. I am your trainer Maurice Monene. In today's session, we are going to discuss how to display numbers in C language, such as displaying the numbers 1 to 25, odd numbers, and even numbers between 1 to 25. Remember, you can have a separate ID and a compiler to run C++ that translates to machine language. But for my case, I'm going to use the code block. I can launch the code block by clicking here on the taskbar, and then it loads. We give it time. This is the interface of the. Then to create a new project, maybe I can go to create new project, click, and then here we can build a basic. So we click on console application to click the basic. So we click and then we click go, and here we can skip this page because we want to leave. So we click maybe next, and then we ensure that we have chosen the C language, and then to make sure it runs, we click next, and here we can give the name. For my case, I'm going to give Maurice. Maurice, and then remember I can maintain this directory. I'm not going to change anything. So I leave it, and then ensure that it is CBP. Then I can click next. So this one I can overwrite the one that I had, so I click yes, and here I can ensure that I have GCC compiler, finish, and then I can overwrite. I click yes to overwrite, and there I am. So to view the project that I've created, I can click maybe on view, then activate the project, and there I have models that we have created. To see the basic build, click plus to see the main, and then we can expand this a bit, and then we can double click to see the basic proc. That is the basic proc. So in this we are going to first of all display the first 25 numbers. So for me, I don't think I need the print f, maybe allow this allow out. So in this case, maybe I can delete this so that I can start building my own code. So the first code, remember, we are going to display, so we can declare the first variable, which is maybe hint x, and declare the first variable, which is maybe the hint x. So remember that one we have declared. Remember to terminate with a semicolon. Then we can add the for loop. We can add the for loop here. Then open a bracket, we initialize our variable here. As initialize, we say that our x maybe is equals to 1. We initialize, remember to separate with a semicolon, and then we can give our condition, that is x maybe is less or equal to 25. X maybe is less or equal to 25, and then remember to separate the semicolon also. Then give we give the updater, which you're going to say maybe x, maybe we increment, that is plus, and then we can give inside the curly braces what we are going to output. Maybe we print f, and then we open brackets, and then double quotes, and then inside we can say maybe we want to print the number, write the number, then separated maybe by a colon, and then we can give the place order or the access identifier, which is the %d. Remember, this one tells we expect a number to be pressed there. Then we separate with a comma, and we give the argument, which is our variable x. Then remember to terminate it with a semicolon. And remember, we're going to retain this return 0 so that we can run our program with no error. Then we can run it. So you can see our numbers have been displaced, but in a continuous line. So to rectify these, we need to go back to our code and add the double backslash and n, which is the new line, so that our numbers can go to the next line. Then we can run it, and there we have a nice looking numbers, that is number 1 to 25. number 1, maybe 2, 25. Then also remember you can change this updater to maybe hex plus is equals to 1. It's just the same with what we have done. If we run this program, we are going, so you can see we have the same number, so you can see this one also means that we are incrementing by 1. Then for us to display the odd numbers, we need to change a bit, so that maybe we can remember the difference is 2 from one odd number to other, so we can add a 2 there, and then we can run our program. Maybe we can learn, we see what you're going to get, and in this case you'll realize that we have 1 to 20, 1, 3, 5, which are the odd numbers, and still you can take it to be maybe hex is equals to hex plus 2. You can also do it as maybe x is equals to x plus 2. We see if you're going to have the same thing. We see if you're going to have the same thing, and if we run maybe these, we can get the same numbers, that is the odd numbers between 1 to 25. So now for us, the next thing after displaying the odd numbers, we need to display the even number. And for us to display the even number, what we need to change is just the initialization. We initialize it to 0 now instead of 1, and then maybe we can try maybe and run it to see if we're going to have the even numbers. And there we have the even numbers between 0 to 25, that is 0 to 4 all the way to 25. So that's how we can display the even number. So next, what I want as we display, I want as we add 2 numbers using the variable. So we can do away with all this and then write how we can add the 2 numbers. So we first by declaring our variables that we are going to use, and also maybe I can initialize it to 2. I can initialize it to 2, and remember always to terminate your work with a semicolon. Then we can declare and initialize our second variable, which is maybe int y is equals to 3. Int y is equals to 3. And then remember always to terminate maybe with a semicolon. Then we can have our last variable to store our result, which is int, maybe we can say result, and then we can add our variables that we have stored our magic numbers in. Remember, these magic numbers we can change each and every time without affecting our code. So remember always to terminate the semicolon, and then we can see what is going to be printed on our screen. So we say print, we print f, and then inside the print f maybe we can have double quotes, and then have the result. We say the result is, and then we can put the percentage d, the result maybe is percentage d. We end the quotes, and then we separate with a comma to pass our argument, which is we are referencing the result variable. We are referencing the result variable, and then remember to always terminate with a semicolon, and then we can learn it. Yes, and there we have our 3 added to 2 is equals to 5. Equals to 5. Let us try to divide these 2 numbers. We change our x to 5 maybe. We change maybe our x to 5, and also we change maybe also our y's to what we can have a difference maybe to something like 2. Yes, and then we can change the plus our operator to division, and then we can leave the other to remain because we also accessing the division. And there you see now we get 2, but we know that 5 divided by 2 is 2.5. So let us rectify that. We can rectify that by changing one of the data type to be either a float, and then remember float out the decimal, so we can put this 1.0, And also remember, we also need to put the result down to the data type, which is a float also, which is a float. And then remember, we have to change the access identifier or our placeholder to %f, and then we can leave the other way there and run. And there we have. But you see now our precision is much increased. So to decrease that, we add maybe the number of decimal places that we need after the percentage. Maybe you can put %1 and run, and see there we have reduced to 2.5. Good. And remember, we can also use the double. Although the double has a higher precision, it stores much bits. Remember, as a programmer, you need to economize the memory. So if we use the float, also we need to pass it to a float, to a double result. And also maybe we change our access identifier to LF, and then we can remove this number of decimal so that you can see how the precision works. Run, and there we have 2.50. The 0, you see the precision. See the precision, we can reduce it maybe to 2 decimal places by 0.2, and there you can run it. There you can have 2.5. So let us run one program with a modular. Let us run one program that can have maybe another number with the modular. So we do away with this, and in this we are going to declare a variable. Maybe we can declare int y. Maybe we can declare int y, or a variable of data type y. And then this one, we initialize it on a different line. We say maybe y is equals maybe to 7 modular maybe 3 minus maybe 4 minus 4, maybe multiply the asterisk, put the asterisk, multiply by 3, and then maybe we subtract 1, and then remember to terminate with a semicolon. Then we can put our printf function here to see what will be printed out, and we put our brackets, our double quote, and then we can, it's an integer, so we need the %d. We need it to be in %d. Then we separate the comma and pass our argument, which is variable y, and terminate with a semicolon, and then run it. Hope it will not have error. Yes, and there it has a result. And that maybe bring us to the end of this. If you have found this video helpful to you, consider subscribing. You can like, share it, so that you can reach more students to benefit. I was Chena Morris Monene.